Every phone charger, every LED, every computer chip is built on one idea. A material that's neither a conductor nor an insulator. A semiconductor. And the simplest device you can build from it is the diode. A one-way valve for electric current. To see how it works, we start with the silicon itself. Picture a spectrum. On one end, a conductor, like copper. It's packed with free electrons, so current flows easily. On the other end, an insulator, like rubber or glass. Its electrons are locked down, so almost nothing flows. Silicon sits right in the middle. Pure silicon barely conducts. But that's exactly what makes it useful, because we can change it. The trick is called doping. We mix in a tiny amount of a different atom. Add an atom with one extra electron, like phosphorus, and the silicon gets spare electrons floating around. That's N-type. N for negative carriers. Or add an atom with one electron missing, like boron, and the silicon gets empty spots, called holes. A hole acts like a positive charge. That's P-type. So now we have two flavors of silicon. N-type, full of loose electrons, and P-type, full of holes. By themselves, not much. But press a piece of P-type against a piece of N-type, and something remarkable happens. Right at the junction, the loose electrons rush across and fill the nearby holes. They cancel out. That leaves a thin zone in the middle with no free carriers at all, the depletion region, and it builds a tiny voltage barrier across the junction. For silicon, about 0.7 volts. That PN junction is a diode. Now let's push current at it. First, forward bias. Connect plus to the P side and minus to the N side. That shoves the holes and electrons toward the junction. Beat the 0.7 volt barrier and it collapses. Current pours through. The diode is on. Now flip the battery. Reverse bias. Plus to the N side, minus to the P side. This pulls the carriers away from the junction. The depletion region grows wider, the barrier gets stronger, and no current flows. The diode is off. So a diode conducts one way and blocks the other. A one-way valve, exactly like we promised. Its symbol is an arrow, pointing the way current can go. And here's the payoff. Feed it alternating current, which flows back and forth, and the diode only passes the forward halves. Alternating current in. Pulsing direct current out. That's rectification. It's how every charger turns the AC from your wall into the DC your electronics need. One practical note. A silicon diode always eats about 0.7 volts. So on a 5 volt supply, through a 1 kilo ohm resistor, you'd get 4.3 volts across the resistor. About 4.3 milliamps. So that's the semiconductor. Doped silicon, a PN junction that combines into a one-way valve, and the diode that rectifies your power. Next time, back to the board. Grab a pencil, and I'll see you there.